All right, so let's give folks a moment just to join here and we'll kick off. Okay, I'm going to kick it off. Good morning, good afternoon, good evening. I'm Michael Maxey, go by Maxey from ZEDEDA, and welcome to Watch Out Edge, the containers are coming, accelerating edge innovation with next-gen collaborative solutions. So today, Carl Moberg from Avassa and I will be talking through some edge architectures. I'm going to be focusing really on the infrastructure layer of edge. And then Carl's going to bring us home with the great container management solution they have on top of that. And we'll be about a half an hour today. We do welcome any questions. So please use the chat feature on your Zoom interface if you want to send in some questions, and we'll save some time at the end to answer those. So with me today, again, is Carl Moberg from Avassa, and he's going to kick us off with some to meet the team. So Carl, why don't you kick us off?
Thank you, Michael. I will. So to build on the point that you made there, Maxi, I wanted to introduce our esteemed audience to the two kind of personas that we're going to talk about today. To your point, on the right, we have a gentleman, Patrick McEngine. He's an edge IT and platform engineer. He cares deeply about infrastructure. He loves to plan, design, and configure infrastructure for a living. And what he does, of course, in this context, because we're talking about edge computing here, is that he makes sure that there's a convenient and efficient and secure and robust edge infrastructure layer, because he wants to enable the other person here. We call her Applifer Developees, and she is an edge application developer. And of course, she designs and plans for and codes the applications that are actually going to run on the distributed infrastructure. So she's very passionate about running on top of Patrick's infrastructure, about the application layer. And of course, the cool thing, among other things, with her is that she really drives the value stream. The applications that she brings about is closely tied to, hopefully, the core business of the enterprise or the company that these two are working for. And today we're going to, of course, explore a combination of our solutions here to make sure that we satisfy the needs of both Patrick and Applifer. And what we're going to bring you today is, of course, something we call loosely the edge platform. And that, of course, is a combination of ZEDEDA assets and ZEDEDA infrastructure combined with what we bring here from Avassa. And at the end of the day, what we're hoping to do, as you may notice, Patrick has a pair of cool shades on him. We're going to make him the hero and make sure that he can install, monitor, and secure really, really nice infrastructure and make Applifer and the application teams happy. But let's start from the infrastructure layer. Let's build this ground up.
Cool. Excellent. Thanks, Carl. So maybe just a quick introduction to ZEDEDA if you're unfamiliar. We're a company, we're very focused on edge orchestration and management. We've been building this solution for a number of years, and it's a combination of some open source technology. So we have a bare metal operating system called Eve that's open source and lives as part of the Linux Foundation, and then a SaaS offering that runs in the cloud. And the combination of those two bring together the ability to orchestrate your infrastructure for the edge. We've been at this for a number of years. I'll take you through a timeline here in just a second, but we have great customers. The team itself is about 100 employees worldwide, built really from a core team that came out of Sun and Ericsson, so sort of deep networking and operating system experience, and sort of been building up over time as we expand the company. On the next slide, you'll see a timeline of the company, and we're almost 7 years old, which, you know, for a startup seems like a very long period of time. But this is really non-trivial work. You know, we've been building an operating system, we've been building a cloud platform, and we've been doing it in a way that really addresses the needs of the edge. And we'll talk a little bit more about what those needs are here in just a minute. But as you can see, you know, the company's been around a while, it's been growing. We've had production customers for almost 4 years now. So we have a very robust solution that's running in some of the biggest, you know, blue chip customers in the world, be they manufacturing or oil and gas, et cetera. And we have a great set of investors as well. And with that, we've been able to really kind of on the next slide, pull together a unique set of customers on the edge. And when we talk about edge, everyone has sort of a different definition. We like to think of it as, gateways or servers running outside your data center. And on this slide, you can see an example of a bunch of different customers that we have. They're doing just that. They're running, Intel or AMD or ARM compute in the wild, be it in a truck or on an oil well or in an automotive dealer, inside machines. And they're doing this in a way where they don't have local IT staff. They don't have local folks to console into these machines. And they're doing it where they're updating software all the time. So this orchestration platform in combination with Avassa's container platform gives customers real ability to kind of not only stand up infrastructure, but do DevOps workflows, CI/CD workflows, and push containers to the edge as soon as they need updates or security updates or any changes to the application itself. And this is challenging because on the next slide, we'll talk a little bit about like, what are the requirements? And one of the most unique things about edge computing is you're outside the data center. And when you do that, it brings different threat models, different challenges, different ways of scaling. You no longer have armed guards or technicians to go fix computers like you do in the cloud or in your data center. Instead, these are distributed all throughout the world and are generally not accessible unless over a network connection. There's also very unique hardware. It's not your standard 1U pizza boxes. We see everything from small Raspberry Pis up to pretty beefy Intel servers and ruggedized explosion-proof cases. So you have a huge diversity of hardware you need to address. And this hardware is distributed all over. So lots of nodes, lots of locations, and typically places where, again, you don't have IT staff. You have people in hard hats doing oil rig work. And they're not really built to log in via a console and push an update to an application or something like that. They're also highly secure, or need to be, because these get stolen. People plug USB keys into them. These devices often contain critical information for our customers. So having a true security model that doesn't rely on people outside the building protecting the device is really important. And then lastly, connectivity isn't always available. We see satellite networks, we see LTE networks. We need to run in an environment where you don't have a constant connection to the cloud or to a controller, where the node can be sort of independent and run. And then when networking comes back, it can resync up. And a lot of these are really new, interesting challenges that didn't occur before edge computing existed. So let's take just a quick minute to talk about how we do some of these compute requirements and how we can build trust in these environments that don't have the classic data center power, cooling, and armed guards. So with ZEDEDA, we have a centralized state model, which means as an administrator, you set your desired state in our SaaS offering in the cloud. You basically use policy to say each node needs these particular applications configured this particular way using these particular hardware resources. And that state lives centralized. You don't command and control connect into a node and configure it like you might in a data center. Instead, you set that central state. And then you choose your device. And there are lots of device support. As I mentioned, lots of heterogeneous hardware that we're seeing out there. You install Eve, which is our operating system. It's the open source component of our solution. And Eve allows you to then ship that device directly to the end location. So you're not staging it in a warehouse and pre-installing. You're basically installing Eve and shipping that out to any remote location. And then once it arrives, on the next slide, there's a whole sequence around how we make sure that device is actually your device. And we make sure that the software running on the device is exactly the software you expect. And this is where a big piece of the security, zero trust, as well as the ease of use, the zero touch model comes in. So what we'll do with every device, and actually every 6 hours, is we run a process called measured boot. And what this does is as it sounds, it measures every piece of software in the boot sequence, everything from the firmware on the device to the Eve operating system, to any guest operating system, up through the Avassa layer, all the way up into the applications. And it measures those software devices in the form of a hash, basically hashes a signature of the applications, and then it tests those with the cloud. So attesting, what that means is it's comparing those values with the expected values. And if they compare and they're correct, what that means is it's the exact software you think it is. No one has installed malware, no one has upgraded anything. It is exactly the software you expect. And then we also use a hardware component in the device called a TPM, or a trusted platform module, which is a piece of hardware designed to hold private keys to attest the device itself. So the end result of this is you know exactly that the software running is the software you expect it to be, and the device is actually your device. And once you're confident that both of these things are true, we then have a trusted platform. We unlock or unencrypt the drives and allow you to deploy applications, right? And that's a big part of the story here is really locking down that infrastructure and building trust. And on the next slide, you can see, like, once that's done, we present up a marketplace of applications, right? And Carl's going to show you a demo of this in a few moments here. But this is fundamentally how an administrator sets that desired state at the beginning and gets applications onto the nodes themselves. We use a fair number of buzzwords on this slide: zero trust and zero touch. I talked a minute ago about how we support both of those. The zero limits piece is about scale. And the key to this, and the centralized state model and the security and the zero touch piece, really allows you to take these to thousands or tens of thousands of different locations. And we have customers pushing nodes out to those numbers today. And each of them are centrally managed through that cloud platform. So we feel that this combination really gives you trust in your software, trust in your device, the ability to push a number of different applications, container management platforms, everything to the edge, with really some zero limits, right? So we're really proud of the system we built, and we think it partners well with Avassa. So let me spend one more minute. I'm going to take you through a quick customer journey that we've been working on with the Avassa team. I'm not going to name the customer here, but they are a pretty large retailer. And they, like many of the retailers and many of the edge customers, they're starting to build really unique solutions for the edge. And it started in retail. It started often with point of sale type of workloads, but more and more they're starting to see use cases like computer vision, like automatically trying things on in a mirror, doing personalized shopping experience. And a lot of these unique applications are either built by third parties or even in-house, which is what happened at this particular retailer. So they, as an engineering team and an innovation team, started building these new experiences for the store and decided it is time to deploy this at the edge. So they signed up with ZEDEDA. We've been helping them. The first thing they asked us to do was, hey, stand up Kubernetes on the edge for us. And we have sort of a native Kubernetes offering inside our marketplace. So with a few clicks, they were able to stand up a Kubernetes cluster using K3s. And we sort of handed over the controls to them and allowed them to go to town. And what we learned as we came back to visit them about a week later is they hadn't made a ton of progress. And the challenge was that they were not a Kubernetes shop, right? They weren't using Kubernetes in the cloud. They didn't have a private cloud running Kubernetes. It was sort of their first experience with Kubernetes. And like many first experiences in Kubernetes, it can be complex. You have admission controllers, you have cluster APIs, you have an ecosystem of a couple thousand different projects that can plug in, and it can be extremely overwhelming. And the fact that they hadn't standardized on Kubernetes anywhere else was sort of their learning curve was extremely steep. So we came back, we had a number of conversations with them. We sort of dug into why Kubernetes, does it have to be Kubernetes? The conversation was, well, it's a standard, it makes sense. We wanted to start there. And after some discussion and sort of looking at their environment and the number of containers they're deploying and sort of the workloads, we suggested, let's take a simpler path from Kubernetes and let's take a look at Avassa. So with that, a few more clicks, we pulled out the Kubernetes piece, we brought in Avassa, and the experience was very different. And Carl's going to take you through why that's the case. But from our perspective, it's a great combination, right? If you're not deep into Kubernetes, you haven't standardized on a particular distribution or a particular orchestrator, there's no need to necessarily go down that path on the edge. There are plenty of great container solutions. we really like Avassa's. It's built for developers. It's a nice combination to our infrastructure piece. And in this particular example, the customer's been moving really fast. They're back to like looking at computer vision and looking at their AI shopping experience instead of spending all their time reading Kubernetes manuals and digging into some of the technology. So this is a good example of how the two companies are working together and how we think we can bring a really interesting solution to not only Platric, but to Applifer as well. So Carl, do you want to take a minute and maybe take the team through a little bit on the Avassa side?
Absolutely, absolutely. Let me put some color to the experiences that we had together, right? So apologies for kind of throwing you into another way of illustrating the same thing here. But on this slide, you will see our beloved friend on the left, Platric here, in the situation where they had actually maybe over-rotated towards building on top of Kubernetes and the Kubernetes ecosystem. Of course, Platric had realized that, Kubernetes in and of itself is nowhere near enough to bring any sort of platform experience or platform as a service experience for the multitude of application teams, for the multitude of use cases, and for the multitude of deployment cycles that is needed in a modern retail enterprise like the one we're talking about. What is normally needed is somewhere between maybe 15 up to 20 different applications out of the CNCF landscape in order to secure the workload, to provide, automated installation of the component, observability, monitoring, all kinds of additional features needs to be installed here. And at the same time, of course, they were interacting with, let's call it their first application team that were going to try and make sure that they were able to deploy on this platform. Now, again, Kubernetes in and of itself doesn't provide any type of self-service developer experience. So they got going with sort of a manual handover process, meaning that they had physical meetings between the application team. In this case, they started with one, where the application team described literally to the IT and the platform engineering team what application they wanted deployed, which version and in which location, and actually at which time to deploy this. And of course, they kind of got going because, of course, if you have basic grasp of Kubernetes and the components, of course, you can do this, even though it's a manual handover. And of course, the good thing was that they were able to use declarative definitions of the application itself. That's one of the many, many good things with the container ecosystem, that defining an application and its constituent parts and versions and the relationships between the containers is a fairly standardized format now, but the deployment was still done in kind of live synchronous meetings. And of course, the thing here was that Applifer, in this case, she was used to being able to actually deploy new versions of applications and actually line up several applications. So what started to happen, obviously, was that as she started, working with the Platric to introduce application number 2 and application number 3 and application number 4, that manual handover process, the lack of a self-service experience, was becoming a very obvious problem. And what exacerbated or multiplied the problem was that, of course, as soon as you've deployed an application, the clock starts ticking towards a second version of that, driven either by feature growth or even worse, by security shortcomings, right? Not only was there a line of applications waiting for deployment, there was also a line of versions, a roadmap for each application. And as that started growing, now this started to become something insurmountable, right? The case was pretty obvious now that manual handover between the application team and the IT team in terms of the applications deployed, not so much the infrastructure, but the applications deployed, was now setting the pace for how fast new applications could be deployed and how fast new versions of applications could be deployed. So there was literally a scaling issue, of course, at hand. And of course, as many things in computer science, you could argue, stepping back maybe 2 steps or more, that there was a lack of abstractions here. There was a lack of well understood handover points of well understood ways and means of communicating between the teams, hopefully in a formal fashion. And so they were looking at a little bit of a restart around how should we communicate, what are the abstractions between these teams so we can make these things go faster, be more convenient, and be more comfortable. And at the end of the day, also hopefully maybe automate this and get full leverage out of the IT operation stacks that both the Platrix and the Applifers had. In short, why don't we let the computers do the hard things and automate all of these components and all of these steps here? And of course, the way we like to think about this is that we want to allow Platrick to do what he does best and what he's passionate about, going back to the way we talk about that kind of persona, that kind of role, is to provide, let's call it an application-centric edge platform, so that he can efficiently and securely, all the good things that you talked about here, Maxey, monitor, secure, and offer a robust and secure infrastructure where it's cheap and efficient to add new sites, and maybe even cheap and efficient to change existing sites or remove sites for that matter, and provide that as something that doesn't actually involve or doesn't have to involve the IT team when it comes to application deployments. Because we want to eventually hand over the reins of the deployment cycle to the teams that owns the faith anyway of the applications, i.e. the Applifers. And for some teams, that means that they have a working plan, as with this customer, to allow the application teams to not only deploy their own applications on the infrastructure owned by the IT team, but also do monitoring, observability, and what the DevOps teams would say, take the responsibility of the service level objectives and service level results of deployed applications. And in order to do that, of course, we need two things. I mentioned that application specifications are kind of mainstream now. So the way you define a containerized application in a versioned manner is pretty well known. But what we're adding here, working also, of course, together with ZEDEDA, is something we call a deployment specification, which is a way for the application teams to formally describe where or under which circumstances do I want my applications to be replicated or to be kept alive. And to us, that's kind of the missing key here in order to provide that nice abstraction between the ownership of the infrastructure with Platrick, of course, living and breathing in ZEDEDA, and the lifecycle responsibilities and the lifecycle operational responsibilities for the application teams, informal definitions of applications and deployments. And of course, you guys can see where this is going, using the Avassa layer on top of the ZEDEDA platform. So what we're talking about here, now I'm trying to make my way towards a demo, is that, of course, on the left side, you have ZEDEDA, the kind of little web UI here is where we'll spend some time in a couple of moments here, is the Z Cloud or the Z Control. And of course, to Maxey's point, they provide this very nice, secure, robust, and easy to work with infrastructure, meaning the operating system layer, the hypervisor layer, providing the means to have a very mixed, if you like, combination of things like a Windows virtual machine, Linux VMs with Linux applications running right on the kernel, or on the user land, to be more specific. But what we're going to focus on today here is kind of the far right edge of that Eve layer here, where we're going to spin up a Linux VM and we're going to install something called the Edge Enforcer. So that's actually one of two pieces of software that I'm going to show you here today from the Avassa platform. So the first step will be that we're going to spin up a Linux VM that will auto install an Edge Enforcer, and that's the Avassa agent. And the thing that does is that it calls home to the control tower, which is our second piece of software here, and it reports the resources that have been made available to it. And when the authentication and authorization of that component is done, Applifer can use then the Avassa side of things to start deploying applications. So this provides that nice abstraction with Platrick building nodes, installing the Eve OS and the underlying infrastructure, and actually giving the Applifers instances of Linux VMs equipped with edge enforcers that then call home to that system that is then able to start defining, deploying, monitoring, observing applications running on top of those Linux VMs. So this is like the architectural layout of that nice abstraction with the IT side on the left and the application side on the right. Of course, at the heart of the collaboration between the companies, of the partnership, is that we're trying to really prove and trying to really, if you like, battle the notion that edge computing is complex, that it's hard, it needs research-like projects internal to IT and application. And we want to show the industry that actually edge computing can be made very, very easy. Of course, on the left side, more or less, you have the ZEDEDA benefits. You pick your favorite edge hardware. Maxey walked you through a couple of the types of hardware that they have very nice support for. You ship that to a remote location, power on the node. EVOS does its magic, and you get automatic device and software attestation. And of course, the demo now that I'm again working towards here is going to take over round about stage 4 here, or step 4, where we're going to deploy that edge enforcer, have that virtual machine and edge enforcer registered in our control tower, and then you actually have a production ready edge platform. And hopefully, if everything goes well here, I'll show you how we can go from, let's say, step 3 here to step 6 in a matter of minutes, and with no manual steps and everything actually done through a web UI. You know, all of this can also be done through CLIs for people that are of that ilk, but just to show you that this can very easily be done through web UIs, and we'll be up and running with our first application. And just not to completely lose you when I start clicking in web UIs here are the actual and literal steps that I'm going to do here in a couple of minutes. I have pre-deployed and configured an edge node in Z-Control. This means that we have a piece of hardware that have EVOS installed in our lab here. It's called home to my account in Z-Control. So it's available for me to start installing or instantiating what Z-Control call edge applications. And we've also prepared in the marketplace that Maxey mentioned an instance of a Linux VM with an installation script for the edge enforcer that we're going to use to deploy an edge enforcer app, meaning a VM, to that host. This instance will then auto-register in the control tower. So somewhere here, I'm going to switch away from Z-Control into the Avassa control tower and kind of switch hats away from Platric, the IT role, into Applifer, the application deployment role. And I'm going to deploy container applications to that newly registered and newly called home cluster. And I will show you bits and pieces of what the application layer platform here does in terms of monitoring the applications, upgrading the applications, providing observability means, and all kinds of other things that are, again, complementary to the ZEDEDA platform and more geared towards the application teams. And hopefully this will come together nicely, and you will find that together we provide a solution from the hardware up all the way to the CI/CD or to the application release orchestration, including monitoring and observability. All right, with that, I'm going to shift over to the ZEDEDA Z-Control UI. Hopefully, some of you, most of you have already seen this view here. This is me being logged in as Avassa Systems at Z-Control. And well, I'm not going to walk you through this. I will jump straight to, as I mentioned, I have an edge node. It's called Kontoret, which is Swedish for the office. And we are ready actually and to look and see that it's actually booted. It's also called home. It's got an HSM. It's got data encryption enabled. So it looks good. There's nothing particularly weird going on here. It is healthy and up and running. And with that, I'm going to switch over and just show you that since we want to build a little bit of an ambitious infrastructure at the edge here, I've already pre-installed 2 hosts or 2 applications, 2 VMs on this host. because I want to build a 3-host or 3 VM cluster here for failover capabilities or for rolling upgrades. So these two are already in flight, up and running. And what I'm going to do now is that I'm going to use the marketplace to fire up a third one. So I go to Marketplace, Edge Apps. And to no one's surprise, there's an Avassa Edge Enforcer app here. And I click the little rocket, and that will take me through the structured steps that is required to start an app or a VM on a known and ready node here. So I'm going to say that, yes, indeed, this is the Edge Enforcer app. I'm going to say that this belongs to the default project. And that means that I get access to the Office node. I'll click through to next. I'm just going to call this host 3 because host 1 and 2 are already taken. And that looks good. We got a network adapter. This is the only configuration parameter needed for the Edge Enforcer Z Control Marketplace app. And it's, of course, the URL for the control tower, because as I mentioned before, as you stand up and as you instantiate Edge Enforcers, they're going to call home to a control tower. It's going to register itself, authenticate and authorize itself, and it's going to tell the control tower about the resources available to it, in this case, in the VM that it's running in. And when that's concluded, that's when we're ready to start deploying containerized applications on top of it. So with that behind us, we're going to click through and we should be good. We are ready to deploy. And I just want to see here that we have started the process. I'm going to go back to the Edge app instances, hit host 3 here and just look at events. And yes, created active. So now we're coming alive here. This actually takes a moment or two, or actually a minute or two even, because it's a virtual machine. We need the image, we need it to get booted, we need to get network access. So I'm going to head over and do some preparatory steps in the Avassa UI. So now I did that switch over. Now we are in the Avassa platform. So I switched hats away from Patrick, the IT team, into Applifer, the application team. And what you'll see here is that we actually have a couple of nodes installed already. So we have about 20 sites already ready here. And on top of this, of course, in the background, we're now adding the 21st site. And I just wanted to show you what it takes now to prepare an application for deployment. And then when the newly started cluster comes up, we're going to actually deploy the application. So we click over here to applications. And of course, as with most web UIs, you'll see on the left side things we can do with this system. And I'm going to focus on the definition of sites, applications, and deployments here, because this is a very brief demo. There are a number of other features here, including distributed registries. We have a distributed secrets manager. Based on vaults, we have a deep tenancy model. We have resource profiles and many other things. But we're going to stick to the definition of sites, applications, and deployments here for today. And what I've done is that I've prepared an application. And it's called Visitor Counter. It is actually one of those applications that is really growing in the retail vertical, but it's a little bit of a made-up application in this case. And as you can see in this web UI here, we literally have two types of users, one that lives their lives in YAML or JSON. So we'd like to show that as well for full transparency, but also people that like to stay inside of the web UI abstraction here. So I prepared a very basic application called Visitor Counter. It's got a single container. It's got a single environment variable that is going to pick up from a vault here. So it's a very, very kind of basic application. Now, in centralized environments, when you configure an application, that usually means that you also want to deploy it. If you do this in a distributed environment, of course, defining an application is one thing, as I mentioned, for Applifer, and then formally describing where to deploy this application is a separate, but of course, equally important aspect of this. So we have configured this application. We just want to make sure that we have found the container images, and we can see that indeed we have. So it's present. We can see the build SHA of the container image that is part of the visitor counter application. And now we want to make sure that we've made some progress here and go back to the Z control UI. Let's see if we have some progress. Yeah, we've state changed from booting to online, so it might actually be up and running already. And as I mentioned before, as Edge Enforcer comes online, it starts calling home to that URL that I showed you. So what we can do here is we can go and have a look to see if we have any unclaimed hosts. And indeed we do. We have 3 now. So we have 3 unclaimed hosts. So these are the 3 VMs that I have started on that Edge node through zCloud. And so they are now ready to be brought into the configured sites that I have. So I'm going to add a site here. And actually, the geolocation mechanism on the zCloud side told me that this was in Alingsås, which is a very small town in Sweden, mostly known for the fact that the potato industry got started here in the 1720s. So I'm going to name it Alingsås. I'm going to actually give it a label. I'm going to say that this is in region Europe because I want to use this later on. And then I'm going to add the 3 unclaimed sites to this, sorry, the 3 unclaimed hosts to this site. And I'm going to submit this configuration. And what this will do now, of course, that's going to create a new site. And it's going to take a moment because now we are going to give the Edge Enforcers on all 3 hosts some updated configuration. And actually, if needed, also update the infrastructure components, the Edge Enforcer, the agent here, if needed. So we're going to give this a moment, and it's awaiting call home. All the call home processing always starts at the edge, obviously, because most of the users in this kind of environment won't allow a centralized control tower to reach out to the edge in itself. So we'll hopefully have this up and running here in a couple of seconds. And what's going to happen now that we also realize that they're all co-located, as I mentioned, we're also going to put them in a failover cluster so that, for example, if we have applications running in this environment and we need to do rolling upgrades of the underlying infrastructure by using zCloud, of course, then we can reschedule applications across these 3 hosts as needed. So we're getting there. We have 2 of the hosts now up and healthy. And we can, of course, go in and look at them and look at what kind of resources is available here, reported back. And you can see that it reports through SMBIOS and DMI what it is that we get access to through the virtualization layer provided by the ZEDEDA platform. And we're actually good. We are up and running with 3 hosts. So at this point, we should actually be able to start deploying applications to this and to other nodes here. And as I mentioned, that's a separate step. So what we're going to do now is define an application deployment. So we're going to call this the visitor counter deployment. And we're going to point to the one application that we have. And we're going to say this is version 1.0. And we're going to use label matching to say, where do we want to run this? So here's where we're going to say region equals Europe. So that's going to match on 9 sites. And this is an idempotent system. So we're going to go and do a fresh deployment in all 9 of them. And we're also going to actually use a canary stage. So let's say we use Finland for the canary stage. So that's a single host. We'll make it a manual action. So now we're actually ready to deploy this application onto a combination of the sites that we had already up and running and the very newly installed 3-node cluster that I just turned up using the ZEDEDA infrastructure here. So we're going to hit submit new deployment here, create that, go over to this view, wait for Helsinki to finish because that's our canary step. And this is the amount of time it usually takes to pull the container image into the local registry in the local cluster, because we need the availability of them there. So we're now up and running in Helsinki with that application. We can click through, make sure that the container is happy. We can, even if we want to, log into the container just to make sure that everything looks good. So now we're actually in the container running on that location. So not actually on the host, because that's usually Platrix's responsibility, but in the container. And that's where Applifer, of course, needs to go if she wants to check how things are going. We can do mean things like killing the command, force a rescheduling of the application, and make sure that it actually comes up again. And then we can go back, look at the deployment, and continue that. So that's going to deploy the application to all the sites, including, of course, to our newly started cluster in Alingsås. It's going to take the same time here to pull the container images in. And we're good. So now we can see that, again, the application is called Visitor Counter, first versions, that is up and running, and all the locations that it's running on is actually connected, including our newly started cluster here running on Z-Control or on Z-Cloud. That's it. That's what I wanted to show you, this nice handover from the infrastructure team into the application team, the definition of an application, the definition of where to run it, and how to get that up and running in a monitored and observable fashion here. So with that, I'm going to switch over to the presentation again.
Yeah, that was great. And I think maybe just highlighting a couple things. I think obviously the UI was used for the demo because people can sort of grok that really easily. But both of these products have pretty rich CLIs and APIs. Most of our customers at scale are driving us through an API versus logging in. But so there's a lot of capabilities around there. You went quickly, but that auto configuration and registration piece is super important. There wasn't a copying of a key or copying of an API token or anything like that between the systems. It was all just done automatically. We can do really advanced configurations there. We showed you a really simple one, but those northbound APIs can be really scripted to do lots of things. Set up data flows, set up all sorts of different things. So you can do really advanced things. And then we didn't have time, but both products have pretty deep capabilities around monitoring and administration. And they're segmented the way you would think. So from the Applifer, the application developer's perspective, Carl showed you, he logged directly into the container. He didn't go through Eve. He wasn't a ZEDEDA. She wasn't a ZEDEDA user. She went directly to the container. And the monitoring and sort of the metrics that were important to that user were there. And then if on the ZEDEDA side, we give you a rich history on the infrastructure layer. You can see CPU utilization and memory and disk. You can also see which applications are consuming what. So we do have a lot of capabilities for day two management. And of course, all of these events can be pushed into your Splunk or your SIEM to sort of do this at scale. But really good job on the demo, Carl. I think first of all, the demo gods favored us. It was successful, so nice work there. But I think it was a really good job just to kind of show people how quickly it can be done. But
yeah, thank you, and I totally agree. I mean, there were many stations along that super fast track where we could have stayed and showed a lot more. But I hope it kind of made sense. We really wanted to put it all together end to end here. So thank you for that.
Definitely. And then I think sort of our last message is, go try it out, right? Like, as we demoed, this can be done relatively quickly. We have a bunch of information available on our website. So if you go to ZEDEDA.com and click on our partners and then the Avassa logo, we've done a bunch of work between the companies to really write up like a solution brief on how this stuff works together. There's a demo, there's the ability to sort of self-register where you can create an account for free and start in effect, bringing Avassa in and doing this hands-on for yourself. Obviously, if you want help, we'd be happy to help you with that as well. But, we've really tried to make this self-service as much as possible because we sort of recognize that, people are busy. They don't necessarily have time to schedule sales meetings and demos from folks. They really want to get hands-on. So we encourage that. if you prefer a longer demo, or you want to kind of get into some of the weeds of what Carl showed, like, please reach out. We'd be happy to kind of take you through the combined solution. But we're really excited about this partnership. We think the sort of, Applifer / Platric relates to the real world. We see IT and infrastructure teams standing up infrastructure and development teams building applications. And that abstraction that we built between these two products works really well for a lot of organizations. And lastly, if you're not a Kubernetes shop but want to manage containers, Avassa is an awesome solution. It doesn't come with all the complexity that you might see in the Kubernetes space, and is really purpose built for the edge. So we've seen great success with the combination of those two products. So thank you all. Really appreciate everybody who showed up. We did record this, obviously, so feel free to invite your colleagues to come back and visit it. If you want to reach out to either Carl or I, you can see our emails are right here on the screen. But we encourage you to go to the website and try it out. Get hands-on, see if it's really as easy as Carl made it look. And if not, let us know, because we're super curious about that stuff. But with that, I think we've come to the end of the conversation. Carl, awesome job today. Great to see you again, and look forward to kind of our next one of these.
You too, and thank you so much for having us.
All right. Thanks, everybody, and have a great rest of your day.